Akamai Technologies is the leading provider of cloud services for delivering, optimizing, and securing online content. The Akamai Foundation helped fund and send a team of 4 female mathematicians of school age to the European Girls Mathematical Olympiad. And we are deeply grateful to the Akamai Foundation for its very generous support of the Advantage Testing Foundation Math Prize for Girls. Our next speaker is Dr. Liz Borowski, a VP of Engineering at Akamai Technologies. As head of Akamai's mapping department, she is in charge of the brains of Akamai's network. Her team runs the software that directs traffic to Akamai's worldwide distributed network, routing roughly 25% of all internet traffic daily. Dr. Borowski started her career in mathematics with an undergraduate degree in mathematics from Williams College and a PhD in theoretical computer science from UCLA. She has worked in industrial research, academia, and industry. Throughout her career, the common thread tying these roles together has been a focus on problems of optimization and coordination in distributed systems. She loves thinking about how pieces of a system in different parts of the world with different characteristics can be made to work together. Dr. Borowski brings her love of worldwide system integration to Akamai Technologies, the leading global service provider for accelerating content and business processes online. Today, Liz is here on behalf of Akamai and the Akamai Foundation. The Foundation's mission is to promote excellence and innovation in math. It is a major sponsor of many wonderful mathematical competitions for young women and men, including the USA Math Olympiad and the Math Olympiad Summer Program. And we are deeply grateful to Akamai Foundation for its support of the Advantage Testing Foundation Math Prize for Girls. Please welcome another member of the math tribe, Dr. Liz Borowski.
Hi, everyone. First, I want to say that I'm just deeply honored to be here in front of all you awesome math women on behalf of the Akamai Foundation. What I do at Akamai is really fun, but working for a company that also promotes math and science engineering amongst youth and amongst girls in particular makes it all the more special to me. Akamai was founded right here at MIT by a grad student, Danny Lewin, and his professor, Tom Layton, who's now our CEO. And it was founded by needing to solve a problem. How do we make the internet fast for end users and workable for the world? Founded with some clever algorithms. They had some interesting ways to solve that real-world problem. And it was founded with passion and dedication by a couple of people and the rest of us who've joined to continue making the internet a great place to work, a great place to do technology, and to have a better future. So my current role at Akamai, I run the group that has the control system for Akamai. So we are the brains behind the network. We come up with the algorithms, some of which Michel collaborated on and started when Akamai was new many years ago. And we're developing every day to solve new things that are going on the internet, 4K video, gaming, response time, emergency systems. How do you make the internet work when there's no power and people can't get to the grid? We work on all those problems, and it takes math brains to do that. People like you, people like me, people who aren't here, but think in that nice, problematic, here's a problem, how do we approach it, how do we put it together way? I wasn't always this much of a math girl. I should confess to that. I've always loved math. I've always been pretty good at it. Well, except in basic computation. Those 5th grade times tables were my nemesis, and there's no way I could solve the page in a minute. So there was a year where math was my enemy, because I understood how it all worked, but doing it like that, I'd get to 4 times 7 and just figure it out, and my minute was gone. So basic computation, never my friend, but how it all fits together, all the rest of it, I loved. So I studied math in college. I didn't take any computer science till sophomore year of my college degree, and I only took it because I was forced to as part of my math major. I didn't know anything about computer science. Computers were new then, fairly new. I'm fairly old. It was kind of a guy thing, you know. My brother took a computer science week-long summer camp and came home, printed out, "His name is great," like 150,000 times. I'm like, yay, great, really interesting. So I took a computer science class, and I actually loved it. It's concrete in a nice way that math is when you've solved a really elegant proof, when you've done something and you have that feeling like, yeah, this is done, this is complete. But computer programs didn't take that long, and they weren't nearly so hard. So you could sit down, you could write a program, you could get it working, tinker out the things, and then it actually worked and did something. And that was compelling for me. So I didn't major in computer science, it was kind of too late, but all the math I loved, the graph theory, and the algorithms and the logic, was all the math that underlines computer systems and computers. So I went to CS grad school. I applied to both applied math and to computer science grad schools, and I decided to go to computer science grad school. I went to UCLA, which was home for me, and it was appealing to go home after being far away for college. I got there, and I wasn't really prepared for grad school, I have to tell you that. I didn't really understand what grad school was about. I went because I had done some research with my math professors, and that was fun. I didn't want to be an actuary. That was the thing to do with a math major where I went to school. That didn't sound appealing to me. The professors seemed to have a pretty good life, so that looked pretty good. So I went to grad school figuring, well, I'll be a professor. That sounds fun. But I didn't really understand what doing research at that level was about until I got there. And I started working. Working with a professor over summer. I took a distributed theory class, and I did a project at the end of the semester on a paper that was really interesting, and he asked me afterwards, "Do you want to work on this?" And I said, "Sure, you know, we did a test run for that summer." He's like, "Why don't you come work with me on this? We'll see how it goes. Next semester you can decide if you want to study with me or if you don't want to." So we worked in the summer, and we made some progress towards a problem that was an open problem at the time. And at the beginning of the year, he asked me whether or not I wanted to study with him. And I said, yeah, this is really fun stuff. I hadn't known anything about it when I got to grad school, but it was really interesting. And he said, okay, there's 2 ways it can go if you're going to be one of my students. You can work on the hot problems, which is what he was working on. You'll get a lot of my time. You'll get a lot of, we'll be working on really important things. But there's going to be a lot of competition. There's a lot of people across the world who are also working on these same open problems. So it'll be high pressure, and it'll be kind of intense. Or you can work on your own topic. We'll pick something that's, not as important and off on the side. It won't be as much pressure. I won't get as much support from him, but that's okay. And so I said, well, let me think about it. And I thought for a weekend, and I decided, I was thinking about it, and I'm sitting here thinking, who am I to be thinking I can compete with these big names in the field? That I could solve these problems faster than anybody else. I wasn't even a computer scientist when I came into grad school. That was hard enough, that everybody had been doing computer science, or at least all the guys had been coding since they were 6, right? And I took my first computer science class 2 years ago. That was tough. But I decided to pretend that I was one of my colleagues, one of my male colleagues. I decided that if looking around, I would just pretend like I had the confidence to solve these problems. And we'd see where it went. And so I said, okay, pretending like I'm just every bit as confident and had as large an ego as all the men around me seemed to have. And I said, let's try these hot topics. Let's try to solve this problem. And we did. So much to my surprise, we actually solved this main problem we were working on that summer. We published my very first paper. We published at a very prestigious, the most prestigious theoretical computer science conference that fall. It got accepted. And we went on to do quite a bit of really fruitful research together and very important work. And so even then, I didn't realize the importance of what we were doing. I was surprised at my own success. I'm glad now. I mean, I'm thinking what would have happened if I hadn't tried it. I didn't expect to actually have that work. But this past year, that very first paper that I ever wrote was awarded the Dijkstra Prize for contribution to theoretical computer science. And so my advisor and I have now won the most prestigious award for theoretical distributed computer science that there is, all because of that very first paper that we wrote. And so looking back on it, I would just say for all of you, you can doubt yourselves all you want. I still doubt myself to this day. I seem confident. You'd think I live a charmed life. I've won this award. I've been a professor. I run a really awesome group of engineers. I solve interesting problems. This was not a laid out plan when I was your age. I had no idea what I wanted to do. The thing I would say that's kept me going is that same type of thing, those little decisions to say, yeah, let's try it. What's the worst that can happen? It can be an utter fiasco. Well, you've learned something. You've learned that, okay, that's not for me, right? I actually became a professor for a while. Not right out of grad school, but shortly after. And you know what? I love teaching, but I don't love teaching the same thing every semester. I like doing research, but I really don't like writing it all up. I like to move on to the next problem and solve the next thing. What do you think you have to do as a professor? You have to write it all up, you have to go give talks, you have to tell everybody how great it is, and then you move on to the next thing. I didn't like those parts of the job. And so even though that was what I thought I wanted, it wasn't. I spent 5-6 years as a professor, and I learned that, you know what, now, even though it's something I'm passionate about, I think more women should be professors. I think role models are really important. That's not for me. So I went off into industry where I am now, where I just get to do the fun part. I get to solve all the problems, make it happen, and make it all happen in the world. So that's my advice to you, is keep your mind open. You never know where life will lead. Do stuff because it's interesting, because it's new. Ask questions, try new things, challenge yourself. Don't take the easy way out. And you never know what you'll end up accomplishing. Thank you, and good luck to all of you. It's great to be here.